Hello teachers, the end of the year is fast approaching, so let's take a quick look at the latest MathFix. Today we are looking at the standard 6.g.4, which looks at representing 3D shapes with nets of rectangles and triangles and finding area in real-world problems. Our problem here has us looking at a situation for a candy manufacturer. We have a task to look for a box that will give us a needed space for our candy, but will cost the least to make. Some shapes are given to start off the conversations, and in addition to their ideas about what box to be used, they also have to support their answer with the use of nets. Little is given in this problem because, once again, the conversation around the problem solving and mathematical assumptions is the most valuable portion of this problem. They do not have the volume needed, but it is a fixed amount, so it is not relevant to the making a choice about the shape of the box. A key part of this problem is actually what does mean to keep costs down. The clue is to use a net. It does steer students towards the materials the box are made out of, but there could be so much more here. In real-world problems, there is manufacturing cost for sure, but for complicated shapes, it may cost more to actually produce those. It may increase shipping costs, and it certainly may be storage costs for really strangely shaped boxes. When we move into real challenges and complications from our problems, then they cease being real and being more scripted. Students need to discuss these real challenges, even if we have no way of calculating the actual costs, which might actually be the cheapest. If you want to extend the concepts within this conversation, then you can bring up the idea of what numbers or types of math they would need to solve a particular challenge if they come up with some strange shaped boxes. So, which shape would be the cheapest? Well, from a surface area to volume point of view, the shape that contains the most internal space to its faces is actually going to be a sphere. A sphere has the least amount of surface area and its volume at the greatest amount, so it would require the least amount of material to make. However, do we really see sphere boxes in our products? It's difficult to make them and transport the goods in spheres. But the next closest shape to a sphere is a cube, actually, and these are much easier to make, transport, and store. If our candy were to be fit inside a cube without actually being broken, then that would be our answer. If not, then the shape of the candy might dictate the actual shape of a more affordable box. There are really so many more fun ways that this could be looked at and supported, so just have some fun with our kids and their ideas. Some really interesting things to think about might be, why don't we build really tall, thin houses? What does surface area have to do with those? And why do we curl up into a ball when we're trying to stay warm? What, again, happens with surface area when we curl up into a ball? And finally, how is space used when you put soup cans into a box versus boxes of soup into a box? Is every bit of the space being used? Well, thank you very much for all your feedback so far, and we'd love to hear more about how you're engaging with this MathFix in your classroom, so please give us some likes and comments in the sections below.